All right, so welcome everybody to an all-new webinar in which we will talk about using Python with the Finch Robot 2.0. I'm Tom Lowers, the founder of BirdBrain Technologies. We're a small educational robotics company in Pittsburgh, Pennsylvania, devoted to inspiring deep and joyful learning for all students through creative robotics. And creative robotics like the Finches, which people on the call will be programming today. I'd like to also introduce our Director of Operations, Aparna. Aparna, you want to say hi?
Hello, my name's Aparna. I have emailed with most of you, so it is nice to put some faces to the names. I'm very, very happy you're here and you've joined us. Thank you very much for your time and for all of your work, working with students and doing creative robotics. We're really excited about so many people wanting to use robotics with Python. So I think this is going to be great. I am going to be in the chat. So if you have any questions while Tom's talking about what he's talking about, or other questions about other programming languages with Finch, Hummingbird, anything else, computer science, robotics related, throw them in the chat there and I will be answering those. And I will turn my video and mute myself so you don't just see me looking at various screens and copying and pasting links in the chat, but I will try to keep up with Tom and post links to the things he's talking about. So if you missed it, you'll have a written record too. Thank you.
All right. Okay, so just to give you a brief overview of what we're going to talk about today. So there's a link to the slides here and Aparna will put that in the chat as well. I'm going to give a quick overview of the Finch Robot 2.0. I think many of you on the call have already used it before, so I'll try to speed through that a little bit, but I think it's useful for anybody listening later also to understand what the Finch is all about. I want to do a deep dive into our online Python materials so that you know what we have out there. Now, as a company, we are very responsive to educator feedback, and the Finch Robot 2.0 is a new product. So please let us know if you see something that you'd like to have created that we haven't created yet. This is an opportunity for you to tell us about it, and we'll try to create it. I'm also going to share a brief opportunity or a brief explanation of how to run the Finch robots that are here in the studio with me using a remote robots technology that we've developed recently. So I'm going to talk a little bit about how that works. And I think at least a few people on the call may actually be using the Finches in that way, using the Finches remotely, so programming them remotely. And then I want to do 3 Finch challenges with all of you, and that is kind of the hands-on portion of this webinar. So I'm hoping to talk for less than half an hour. You can all hold me to that, so that there's about a half an hour for programming and playing around with the Finch robots. Okay, so where did the Finch come from? So the Finch Robot 2.0, as you can probably guess from the name, is the second version of the Finch robot. The first version was developed at Carnegie Mellon University in the late 2000s as a tool for engaging students in computer science at the time, at the high school and college level. I mean, if you remember, 2008, 2009, people weren't necessarily talking about coding in middle and elementary school. But the mission of the robot was to engage and excite students in learning computer science. And when we had an opportunity to redesign the Finch, we wanted to keep that goal, that mission of the tool, but we realized that with the technologies that had been developed over the last 10 years, we could really extend that all the way from kindergarten to college. And so we say that the Finch is a tool for engaging students in computer science and computational thinking at any level. The new robot integrates 10 years of feedback from educators who used the original Finch in the field, told us kind of, the things they liked and didn't like about it. So it's really gratifying to have it out there because, I'm an engineer, and with this new version, I got to essentially improve upon a lot of the things that I've been wanting to improve upon for years. The way we make it work from kindergarten to college is by making it programmable in lots of different programming environments. So it works with icon-based environments, environments that students don't even need to read in order to use. It works with block-based environments, environments that look like puzzle blocks, kind of like Scratch or Code.org, that style of programming, or Blockly. And it works with text-based programming environments like Python or Java, which we'll be using today. So Finch is available now. And I just want to show you kind of what those programming environments look like. So here's 2 snippets of code: Finch Blocks, which is our app for kindergarten to 2nd or 3rd grade, and Python. And what's interesting about this code is that it does the same thing. So it moves the Finch forward and back. Now with Python, you can do much more interesting advanced behaviors, like you could have the Finch recursively draw a fractal. That's not something you can do in Finch Blocks. But at the basic level, all of these environments can create the same behaviors in the Finch robot. So a little bit more explanation of Finch Blocks. That was level 1. We actually level the app Finch Blocks so that students, as they learn, even within that app, they can do more things at higher levels. So level 3 introduces loops. It has some wait untils, like this, wait until dark, or trigger when it's dark, so it has events. So it has, basically the entire philosophy here is that as students learn, they can do more interesting things with the robot. And that should motivate them to continue learning. So Finch Blocks, I should mention, works on Chromebooks, iPads, Android tablets. We're also working to get it available on Windows and Mac. That should happen very soon, actually. Now, when it comes to block-based environments, we actually have a lot of different environments. Bird Blocks is our tablet app for programming the Finch, so it works on iOS and Android. Snap is a computer-based, block-based environment that is live. So by live, I mean that when you click on a block or a set of blocks, you instantly see it happen on the robot. And then MakeCode is a program that you download to the robot. You generate programs that download, so they compile and download. But what MakeCode brings is a really powerful blocks to text editor. And you can actually convert those blocks into Python or JavaScript code. Now that said, we're actually using a different version of Python. We're using standard Python today in order to program the Finch. So let me show you kind of the environments for text-based coding. So Python works on Windows, Mac, and Chromebooks. Java right now works on Windows and Mac only. But we do support both of these environments. And we specifically support standard Python. So you would use Python 3 with idle or Paizo or any regular editor that you are using, most likely in a high school Python class already. Okay, so what's in a Finch? It's a small robot. It has wheels, so it can drive around, obviously. Those wheels have encoders, so it knows how far to travel. You can command it to go 10 centimeters, turn 90 degrees. It has a centrally mounted marker holder, so it can draw shapes literally with a pen mounted in the center. It has a full color LED in the beak, 4 full color LEDs near the tail, and then this LED array of 25 LEDs in a 5x5 grid, which are surprisingly powerful at creating or showing emojis, patterns, animations, and also just printing out text. You can definitely read, character by character, a message that's being printed on that LED array. It also has a buzzer, so it can generate, I say, like 8-bit Nintendo sound. So 1980s Nintendo, not 2020 Nintendo. And then in terms of inputs, it can track a line, it can follow a flashlight beam with light sensors, it has a distance sensor so it can avoid obstacles. It has a compass, so you can make it always drive north. It has an accelerometer, so it knows its location in space, so you can pick it up and use it like a game controller, make a weird musical instrument that changes its pitch as you tilt and roll the Finch. And it has a couple of buttons. So we designed these to be durable. I mean, we heard from teachers about the most common failure modes, let's say, of the original Finch. The most common one being it got stepped on. So we actually built some systems to make sure that if you step on it, nothing happens. If it rolls off a table, it should be able to handle that. I don't recommend you testing this necessarily, but you know, if it happens accidentally, it's no problem. It has a battery, and that battery lasts all day. So it's designed with the idea that you would charge it overnight, and you could run it in every period of the day, and it will still have plenty of battery life after you've done that. And then most importantly, it comes with free lessons and tutorials in all supported languages. And we're going to talk through the Python ones, but know that our support for the other environments is just as comprehensive as for Python. All right, so let's talk about those materials. So I'm going to go to this link. So if you're interested in any language at BirdBrain Technologies, you can just do /finch/ whatever the name of the language is, so /snap, or you can use our portal to get there. But let me go there and maybe make it a little bigger. So we have different kind of starting points here, right? So install instructions, hopefully you only have to go through these once. But these help you set up your Finch for use with Python. So on Mac and Windows and on Chromebooks, it'll basically tell you how to get started, how to download things like the Bluetooth firmware to the Finch. So the way that we work with Python is the Finch kind of gets a special program downloaded to its microbit. And that's actually right here in step 3. You download that program, and then it becomes a Bluetooth device when you've downloaded that program. And now you can connect to it wirelessly with a computer or a tablet to program it. So I'm hoping that everybody who is listening along at home and has a Finch has gone through this step and has downloaded the program onto their Finch. So there's instructions for getting started. There's instructions for how to connect. So once you've got your Finch, you've turned it on, you've downloaded that program, how do you then connect it to your Mac or Windows computer? And then there's some information about programming it with Python. So how to install, start by installing the Python editor, of course. Chromebooks have a similar kind of procedure, especially for getting started and connecting. But once you're in the connecting step, you can actually use something that is browser-based called Brython, where you look for the robots and then you actually have a Python editor in the browser. So that's something that allows us to work on Chromebooks, even though you don't necessarily have like an offline Python editor on Chromebooks. So that's the install instructions. I'm going to spend more time here. So these program instructions are designed in such a way that, they're really meant as sort of a supplement for like an intro to Python course, like a Python course where you're going to get into a fair number of concepts, variables, loops, conditional structures. And the way we've set these up is they sort of interweave Python concepts, so concepts that you'd ordinarily be teaching in the course, along with features of the Finch, so outputs and inputs. So, lesson 1, once you've done the installation instructions, lesson 1 is all about moving and turning. Okay, so what do you need to do there? You learn how to import a library, because you need the Finch library and the Finch object to do anything. And then how to use, an object of that, like the methods of that object. So it will tell you, what is the line of code you need to import the library, how to declare the Finch object, and then how to make it move, right? So just the methods for making it move, set move and set turn. And it takes you through these. The way these lessons are structured is, once you've learned kind of a little nugget, sorry, I'll get rid of that. Once you've learned a single thing, like, how to move your Finch, you get an exercise to either try this out. I mean, obviously the exercises, the prompts get more complicated as the lessons progress. But here's a like make it move forward and backwards. So this code makes it move 25 centimeters. The exercise is to make it move a few more times and only 15 centimeters. So again, sort of miniature prompts, I guess, to have the students practice these. So like the end of this one is to draw a simple picture with the Finch. So make the Finch draw a square or a triangle, something like that. Or put some tape down and have the Finch traverse a path, perhaps through a maze. So have your students kind of figure out, okay, how do I move and turn to make it go through that maze? Now, you know, we try to make these sequential. So, you know, we are assuming in this lesson that you have not learned how to make a loop. You have not learned how to make a variable, right? So this is lesson 1. Really, you're at the stage where you're just creating a sequence of actions, you know, sort of the most basic definition of an algorithm being like a series of steps. The other thing I want to show you, and I think, right, so if you're looking for the code for these exercises, it is provided. We put it behind an access kind of request. And so if you wanted to get that access, you can register. We basically check that you're a teacher. So you have to enter like an EDU email address or show us like where on the staff directory at a school you are, so that we're not accidentally giving the code away to people who shouldn't have it.
Right.
So that's essentially the structure of these lessons. And just to go through, you know, the Python concepts that are covered in the lessons are, you know, pretty clearly shown here.
Yeah, they are.
So, you know, we start with declaring an object. We go through and talk about data types and variables. We start, you know, then we go to user input, if else, then loops, then generating random numbers. This is not an accidental sequence of concepts. We kind of looked at most high school Python classes and we picked a sequence that many of them follow. Not all, but you know, as I said, these are intended as sort of supplements. So it's, you know, it's not the end of the world if you decide to introduce loops before if-else statements, right? You might have to do a little bit of rejiggering of how the lessons run, but I don't think it would be that much of a challenge to come up with some exercises for the Finch that use a loop but not an if-else statement, or use a loop but not a variable. But yeah, so this is really where I think this page, the program page, so these step-by-step lessons are probably the most important teacher and student supports for Python. And you know, they should be hopefully very useful. And again, this is where we're really interested in feedback and you know, any changes we can make, any additions we can make. And Bill, I see you're raising your hand, so go ahead.
Oh, I'm on. I hope I haven't burped too often. What I'd like to try to do is to ask if we could, I'm so sorry. If you have considered using what's called the Google's text editor, and here's why. As you have shown, students will effectively begin to learn how to be able to code as they can be able to play with it. Your blocks, your snap, those other tools are exceptional. Your Brython is outstanding. That's the thing that we use for our Chromebooks. I mean, our Chromebooks. And I began to realize as I'm working with the students that, you know, they need to practice and then apply it. And so what they couldn't do was just that in a Brython thing, unless, you know, you began to try to rename it or you figured all that out. So what I began to have them do is literally create their Python file, a .py file in it. And as soon as you rename it to py, you know, the color editing of Python comes in so that you can nicely feel more confident when you're typing, your commands in those. So I just thought that might be something you might want to consider, because we use it very well, and it allows us then to also save the file, comfortably, elegantly, without having to get out to Brython or have it try to download and rename the Brython file from, the Finch test.
Yeah. I'd like to, well, I mean, I don't want to stop the webinar to discuss this, but I definitely want to hear more about that after the webinar is over. So I'd like to see kind of an example of that.
I'd love to show it, and that way, if you would like, I could also show how I have all of your Python files, classes, and everything already established in the Google Classroom.
Yeah.
So that, our students have it, and depending upon the speed of one student versus another, each student can therefore begin to go ahead and move depending upon their capabilities at their own speed.
Okay. Yeah, I'm very interested. So thanks, Bill, for that.
Thank you.
Okay, so the other two tabs, I'll go a little bit faster. There's the library tab. This is mostly just a reference sheet. Notice that you can print it. You can also print it to PDF from within that. But it's basically an overview of the Finch class methods, so that if you're wondering, okay, so how do I make set move work? What are the arguments? What are the ranges? You need that information, right? So that's what the library section is. And then resources are actually common to all of our programming environments. So this is the same page regardless of which programming environment you start with. And it just shows there's descriptions for the blocks, which for Python you wouldn't need. We have it's a printable resource. It's a 3D printable phone cradle, so you can put your smartphone on it. And then we have some additional support pages here, like our reading list, grants assistance, standards. So just lots and lots of things. And we're constantly adding to this. And again, this is another place where if you are looking for something that we don't have, let us know. We'd be happy to make it.
How do you get to that page, Tom? On the library or resources? My apologies. Thank you.
Yeah. All right. So let me go back and talk briefly about remote robots. So you can actually program the robots that are in the studio with me. So they're visible here, these robots, from anywhere in the world. And the way that we're doing that with Python is to use shared network drives. So there's a full tutorial for how you could set this up yourself. We've seen a couple of teachers start it. This is very new. It's about 2 months since we started developing the way to do this for Python and Java. We'd actually had remote robots capability for block-based programming for most of the last year. But the way it works is essentially you would connect, one or more robots to your Windows computer. It's Windows only right now on the teacher side. You download a modified Python library that you can get from this link, and then you run a file called or a program called runremotepython.exe, and this starts a monitoring program that basically looks for any Python files in the folder that change and then runs them. And what that means is that if you have a shared network drive and your student changes their program, and if you're familiar with how Dropbox works or really any of these network drives, as soon as they change it and they hit save, it goes to the cloud, and then it syncs up with your drive and it updates. And this process turns out only takes 5 to 10 seconds from when I hit save on a remote computer to when it starts to run on the local computer. So for the students, it's actually really easy. They just write their Finch programs. They don't compile them. They save them, and then they can watch it run over the internet. And there's the program actually generates a log file. So if they have an error in their program, like that goes through standard error, standard out, it'll show up in the log file. Probably their robot also won't run or won't run as expected. So actually a pretty simple hack to make remote robots possible. There are limitations. You can't have user input, at least the way we've we've configured it so far. So you can't have a program where you're asking a user for an input. And there's no way for the students to shut things down if they make an infinite loop. So it does require some wrangling on your part. This really does have to be something that you're doing, you know, live in a synchronous teaching session, most likely. But it works. And it works, I think, in a way that supports hybrid teaching also, because you could have an arena for the students who are remote, and you could also have students in the classroom, and they could essentially be working on the same types of programs. So just to talk about these terms that we've defined over time is, you know, when I talk about remote robots, I'm talking about this model where you have the robots as the teacher, you want students to program them over the internet and view them through a camera. One-to-one robotics is where everyone has a robot and you're all in different places and you need to teach or coach effectively. So this webinar is actually a great merger of these two, because some of you have robots. So you're in the one-to-one robotics use case if you've got robots. Some of you may be programming the robots here. So this is essentially a hybrid situation that we have going right here. And with that, it's 4:30, so at least on the East Coast. So I have talked enough, at least to start. So I have a challenge, and I will do part of this kind of synchronously. But I think it is time, if you have a robot, to turn it on. And then I'll give, for the people who are programming remotely, I'll give a few more instructions after we've sort of talked through drawing a shape. So if you have a robot, I have my robot here. I'm going to turn this guy on and connect it to the Bluebird connector. So let me find that. My majestic forest tuna. Okay. Now, let's see. Okay. So this is a folder. This one's actually set up for remote coding a little bit, but on the website, when you use when you're using Python with the Finch, you want to be creating your programs inside of a folder that you download from our website. And I will go to that exact step in the install instructions for anybody who missed it in the emails that we sent before this. So let's see here. Okay. And this is for Windows or Mac only. So you want to go to the programming step 2 and download the BirdBrain Python library. When you do that, you'll see there's a folder called BirdBrain Python. Go ahead and extract that somewhere. And then the Finch test Python file is a starter file that you can use, or you can start creating your own. But why don't I just go through this and I will extract this file so that I'm basically doing the same thing you would be doing. So I'm just going to put it here. And I'm going to open Finch test in idle. So idle being kind of the standard programming IDE for Python, the one that it comes with. There are other ones out there that are available. I'm gonna, just so you guys can see it better, I will improve this a bit. Is that good for everybody? Visible, readable? Or should I go? Okay, I'm seeing some thumbs up, so that's good. Okay, so I've got, a starter program here. So I'm doing the from BirdBrain import Finch. I'm also using time. The first lesson doesn't even require the use of time. We don't have sleeps. But the second or third lesson, I think you get introduced to the notion of putting sleeps in your code. which tends to be more important for robotics than it does for some other programming, because you need to, sometimes pause what you're doing in order to see it in the real world, right? If you flash a light, if you turn the light on, then turn it off immediately, you won't really see that. You need to put a sleep between them to see it. So anybody have any guesses as to what this code does?
Gonna blink the light?
Yes, exactly. So it's a blinky light program. It's going to set the beak, so the light in the beak, to white. And the reason I say white is because we're turning red, green, and blue all on, all 100%. So that makes white. We're going to wait a second. We're going to turn it off. We're going to wait a second, and we're going to do it 10 times, right? So this is a for loop. And then we call this stop all. So there's a couple pieces of code that we reckon that are kind of needed in all Finch programs. And this is one of those things where you want to explain this to your students and make sure that they understand. Like, so the first is, you have to get the object, right? You have to declare that object. And then the last piece is this call to stop all. What that does is it turns off the motors, turns off the lights, basically makes sure that if let's say you didn't do this and you had turned on the motors as your last command, your Finch will just keep running forever, right? So you want to call stop all at the end of any program just to make sure that your Finch is stopped. So now I'm in idle. I'm connected to my robot. So if I go to run and run module, my Finch is indeed blinking. So put that up there. Okay. So, let's see here. So in order to do this first challenge, what we want to do is draw a shape, right? You can pretend either that this is lesson 1 and you haven't even learned about loops, or you can pretend that this is lesson 3 or 4. You already know what a for loop or a while loop is. But your challenge here is to draw a shape. So I'm going to give people about 5 minutes. If you finish that challenge, if you draw one shape, see if you can generalize it to draw a regular polygon of side n. So this is something I like to do in general, in terms of differentiation, is like give people a challenge, but if somebody finishes, you kind of want to have them, you want to follow that up with something, right? So, so the high ceiling activity is, see if you can make it so that you declare a variable n, and let's say if you set that variable to 6, it draws a hexagon, and if you change it to 8, it draws an octagon. So I will just do the first step of drawing a square. So I'll change my code here, and I'll do just one side of the square. So set move F. I'm going to go. So the second parameter here is, it actually auto tells you what the parameters are. I'm going to say 15 centimeters at 50% speed. Then I'm going to go to set turn. I'm going to do a right turn 90 degrees at 50% speed. And if I run this, my robot is moving and turning. You'll just have to believe that happened. Yeah, so let's give people like 5 or 10 minutes with this. So here's a little bit of code and the challenge. All right, now, does anybody need to control a remote robot? Let's see. So yeah, kind of either raise your hand, using like a Zoom reaction, or type in the chat if you need to control a robot remotely. All right, I am actually not seeing anybody, so maybe everybody has a robot, so that's good. Yeah.
I have a question, Tom. So once I opened up the Bluebird connector and it found the Finch, it gives me the snap option. Do I have to do anything at that point?
No, that's a great question. So, so this button allows you to open the Snap programming environment,
Yes.
but you basically, for using it with Python or Java on Mac or Windows, you would not click on Snap. Like once you've got it connected, this is basically like a little utility that's allowing the Python code to communicate with the Finch.
Right.
Okay.
So you don't need to do anything additional with the Bluebird connector once it shows as connected.
Okay, so then when I opened up the Python program in idle, it gave me in RAN, it said error, device A is not connected, invalid connection. So.
Okay. Let's see. So device A. So when you open the Bluebird connector here, do you see it as listed as A? Like, do you see the robot like a Finch here and then a letter A next to it?
Actually, when I clicked on it, it's actually the wheels are just spinning right now.
Oh,
So-
okay. So it may not be connected yet.
Should I disconnect and then try it again?
I should say also, if the wheel's spinning, make sure that that the Finch is not plugged in over USB. Okay.
Interesting.
Eileen, I think you're muted.
Yes, I was talking,
Okay.
all, but
Sorry.
on the side, can I do remote because I was not charging my robot? What? Maybe it's working. I don't know.
I see its initials flashing.
Yeah, initials are flashing and it's disconnected. Maybe my Bluetooth. I need a Bluetooth update or something. Is that the hex file that we had in the beginning?
If its initials are flashing, if it's showing you the 3 letters, then the firmware is on there. So
Oh, okay.
that's good. What computer are you using? Are you using like a Mac or Windows or?
This is a laptop that recently got like scrubbed and ghosted because I did too much crazy stuff on it.
So here's why don't you try the Brython web app?
Okay.
It seems to work on most, like even though it's our Chromebook solution, it actually works on most Mac and Windows computers. So I'll put the direct link, or I'll have Aparna put the direct link in the chat to it, but yep, she's got it.
Okie dokie.
So it's a good fallback if you didn't even install Python on the laptop or the Bluebird connector, you can always go with the Brython web app.
Yeah, this will be good because I still have, we're not supposed to, but we still have Windows 7 desktops in my classroom, and you can't download any newer versions of Python on Windows 7.
Yeah, okay, so those might be a challenge. We can talk about it offline to see if they'll work. They do, with the web apps, the thing that they need is built-in Bluetooth, and typically Windows 10. I haven't seen the web apps do well under Windows 7.
I'm not sure who that was who's still on Windows 7, but would you like the name of my favorite refurbished computer vendor?
We at Hanover County have just, wait, this is recorded. I mean, maybe.
All right, careful everybody. Yes, we're recording this. It's going on YouTube. All right, how are people doing? We can move on to the next challenge. I see George has drawn
Oh,
a triangle, I believe.
Nice triangle.
Yeah, very good. Okay, let's move on. If you're, if you're still working on challenge 1, that's perfectly fine. Feel free to keep asking questions. The next challenge, and actually I'll just talk through both of the next 2 challenges and just let you guys work on whichever ones you want to. I mean, you have access to the slides, right? So challenge 2 is just to make a light show. So use the LEDs, the outputs. So especially the set beak and set tail methods. So see if you can make it flash, use the sleep to time things appropriately. And then your high ceiling there is to make a Finch dance party where you have it move around, maybe in sync to the lights and possibly also sound. So again, you can go, if you've written a lot of Python code, you can go back to that library description and just see how the Python methods for setting the buzzer or setting the wheels of the robot, what you need to put in there. And then the third challenge is to get it to avoid obstacles. Now this code does that, but doesn't do it. What it will do is it changes the light based on whether the distance sensor sees something that's less than 30 centimeters from it. But first of all, this doesn't move. But more importantly, this is not reactive or responsive. So this checks the distance sensor one time and makes a decision based on that condition. If you wanted to make a true obstacle avoider, you'd need to make sure that you are checking that sensor all the time and responding accordingly. So I'm going to leave this snippet of code up because it's kind of the most code that we've got. But please ask questions. We've got about 10 to 15 minutes of programming or playing time left. So ask questions, show us things if they're working. Yeah, and enjoy.
Okay, I got mine working in the Python. I'm very proud of myself. Do you have a test program that, I'm spoiled rotten, do you have a test program that has a little bit of everything, like moving, using the sensors and stuff like that, that we normally get through NetsBlocks?
Do you have the educator access code?
There's an educator access code?
Yeah. So
probably not.
So
I'll send it to you, Eileen.
Yay!
I'm sure you're already signed up. Every list we have, I'm sure you're on.
Yep. But then what I would say is if you need that, go to, like, let's see, maybe buttons in the distance sensor, and then take a look at the teacher materials there. That'll have, put in the access code there. That will have solutions to all of the exercises in this lesson, which includes the obstacle avoider, to be honest. So anyway, there's lots of resources for you.
Yeah, it looks like I'm going to have to make a new set of Finch Python cards.
Yeah, that's likely true. I mean, things, we kept some things the same, but certainly with new technology, there's new capabilities. Got more LEDs and motors that can move accurately. So definitely we needed some new methods. George, I think you've got a question?
Yep.
Yeah, so on the web documentation, when you declare which Finch you're using, you don't put any parameters inside, but in the Finch test you do. I'm assuming that means you can have multiple Finches connected at once?
Yeah, that's a great question. So and keen eye on noticing that. So in this Finch test, you know, when I declare this this object, I'm using a letter to designate it. That's because in Python you can actually control up to 3 Finches simultaneously from one program, which is pretty fun, right? Like you could have the accelerometer of one Finch, you know, you tilt and roll that Finch and you remotely control a second Finch. So the way you would do that is if you had multiple Finches, let's say that I wanted to add a second Finch here. So I'm gonna find robots. You know, so I've connected a second Finch now, and now I would instantiate a second object. I have to call it something else. So let's call it my Finch B. I'm not very creative here. And then, you know, you could have them basically both move at the same time. Or, well, in this case, it'll still be sequential. But, you know, A will move, then B will move, then A will turn, I think. Let's see, live coding here. So A moved, B moved, A turned. Yep.
Thank you.
And you can do that on Chromebooks too. So you can have up to 3 pretty much with any version of Python we've got.
Tom,
Mm-hmm.
I'm trying to get my Python to move, and it says attribute error, Finch object has no attribute set move.
Okay. Huh. So you have the from bird brain import Finch, and you've declared it. Make sure that the Python file that you're using, is that located in the folder?
I believe it is, yes.
Okay. And then on set move, I guess the other thing I would check is, you know, dot set move, capital M. I think it is case sensitive. And then, you know, making sure that there are 3 arguments. I'm trying to think.
It might have been the capital M.
Okay.
Yeah, it was a capital M.
All right, great. I'm glad I
Okay.
was able to debug that in real time.
Thank you.
Sure.
Grammar, always the downfall, hey?
Yeah, and you know, syntax, right? Like every language is different. So I always put semicolons at the end of my statements, and then I remember that I'm in Python and I don't need to do that. And I often forget the colons when I'm making loops or if statements in Python. So yeah.
Awesome, thank you.
Mm-hmm. All right, I'll give people about 5 more minutes. It's good to give you a warning so that, you know, of course, most of you have robots, so you can keep programming. I've been doing these webinars where it's mostly remote programming, so people are programming the robots that are here, and then I have to like cut them off at the end of the webinar. But you guys can keep going. Great.
Tom, in the chat, someone had asked about an STL file for the plastic block adapter, and I posted the link to the phone holder. I thought maybe you might want to tell people about that and what it is.
Yeah, so I actually have my phone mounted to it. So if you look at, I guess, the mini me in the corner. Here's a phone mounted to a Finch, and it's using this printable phone holder, which is basically a two-part design that mounts on top of the, it uses the little Lego pegs on the Finch to position itself, and then it also goes through the marker hole to kind of snap this holder into place. So it's actually quite sturdy. Like I can pick up the Finch with the holder, it's no problem. The phone itself is just attached with one rubber band. You can add rubber bands if you're paranoid about it, but I'm fine. I'm comfortable with one. It's fine. And what that allows people to do, we kind of have 3 use cases for it. One is just GoPro style videos, right? Like you can record a video while the Finch is moving. It's a lot of fun. And that you can do with any students of any age. A second is for kind of remote robot style playgrounds. You can have a camera view that you have, in Zoom that your students can see that is mobile. So that's really fun, right? They can drive the robot around and they can see it through its eyes, kind of. And then the third use case is for, more advanced students who are doing app development, because we have libraries for students to write their own apps that control the Finch. And then if you mount your phone to the Finch and you've written an app for it, you could do things like computer vision, right? You can have the Finch track an object using the camera on the phone. So it seemed like there were enough compelling reasons to make this that we decided to go ahead and get it designed. So it's a fun thing for sure. And if people really love it and they don't have access to 3D printers, that's feedback we want to hear too. Maybe there are ways we can, make it out of kind of more traditional plastic, sort of make a batch of them. All right, anybody have
don't forget, using the phone holder makes it easier for you to raid your principal's office.
That's right. Uses the Finch as a spy cam.
I'm just talking about ambush, just a whole bunch of robots going on with the phone.
Hey, Dave, you were mentioning about your 3D printer things, and we do use MakerBot, and I was thinking of trying to make an avatar for the bird that would be able to sit on top of the pin that's running around. What were you discussing?
Let's see.
What do you have something already designed, Dave? Did I say something wrong?
Oh, sorry, Bill. Were you talking to me? It's Tom.
Yes, sir. I'm so sorry, David. I was hearing you talk about 3D printing, and I in fact have been actually creating lessons using Tinkercad and MakerBot so that they could create an avatar for the little bird that would sit on top of the pin that's running around.
Yeah.
But I wanted to know what have you made, or what are you providing?
So it's a phone mount. So it's printable. You can download the files for free, and it lets you mount a smartphone to the robot.
How cool is that?
Like mounts to, it's basically like a peg through the bottom, and then it snaps into place.
Hey, Tom,
Dave,
there's a.
And how do I get a hold of that?
So Aparna put it in the chat just now, actually. I think that the most recent link she's got in there.
Thank you.
So there's a tool that would be handy in conjunction with that. It's called OBS Ninja. It uses WebRTC, I believe, anything with a camera, so phone would qualify. And then you get a URL from that you can drop into OBS as a browser source. I think you're using OBS today, right, Tom?
Yeah, we're using OBS to.
So that would let you bring that Finch eye view into Zoom without joining another client to the Zoom meeting.
Huh.
Cool.
Yeah, that sounds pretty cool.
God, if we, I'm not sure. you might want to write that up. That'd be something that I think many of us would be able to take advantage of. And I'm pretty sure that would also be a benefit for Dave and our bird brain stuff.
Yeah, cool.
Well, we're pretty much OBS experts over here at Exploration Place, so maybe I'll try and provide my email to anyone who's interested at the end.
Thank you.
Yeah, I might follow up with you, Ian. I think I'm now an intermediate OBS user.
I was going to
definitely
tell
have-
you to maybe consider not plaid for your shirt.
Yeah,
next time.
I'm noticing that myself.
Yeah, it's
That
called
was a
moire. When a grid's misaligned with a grid just behind, that's a
Mhm.
moire.
Terrible. All right. So it's just about 5 o'clock. So I'm going to finish up here. Just wanted to thank everybody for coming. If you didn't have a Finch, or if you're watching this later, please know that if you're in the US and teaching at a school or a library, you can request a demo of the Finch Robot 2.0 or of our other product, the Hummingbird Kit, or both. We are happy to get them out to you to try for 60 days, absolutely free, because we think you'll love them. If you would like to purchase a Finch, here's the link for that. And then you can also sign up for our mailing list. So Aparna, do you have anything you want to add before I stop the recording?
No, just thank you to everyone for coming and great questions in the chat. I apologize. Somehow the settings are such that you can't chat to everyone. So I was very busy chatting with many of you individually. I still can't figure out what's different about the settings this time, but hopefully we'll figure it out for next time. But thank you. Great questions, both in the chat and unmuted. And we're happy to keep talking. So keep emailing us, keep interacting. We love the feedback, and we really love to hear what you guys are doing in your classrooms, in your museums, in your libraries.
Yeah, wonderful. All right. Thank you, everybody, for coming, for watching, for playing with the Finches with us.